And so my plan for the student symposium is for it to count equivalent to a seminar, you must attend an entire session, which is 4 or 5 talks, depending on which session you go to. You'd summarize, each of the talks are only 10 minutes, maybe 15. And so you'd have to attend the entire seminar or session and summarize all the talks within the session. It also counts for CE credits. So if you go to an entire session, you get a CE credit. So it kind of double dips in that way. So that'll be, and the poster session in the evening doesn't count towards credit. Yeah?
When you say summarize, is there only like 10 or 15 minutes? It's like a couple of sentences?
Yeah, that'll be fine. Yep, because they're short, you can only do a few sentences. Questions about that? Yeah.
How many is it again that we can get extra credit?
You can do up to 5 summaries, which will drop up to 3 quizzes. Yeah.
So if we're in like 1 hour increments, but going to 2 hours count as 2
Mm-hmm.
hours?
Yeah. So if you do 2 sessions, that counts as 2 things, as long as you summarize everything. So the first one is the first one, the plenary session is the longest one. It's like 11:30 to 12. Maybe it's 11 to 12:30 or something like that. It's a long one. But everything after that's about an hour. So
we still don't have Tuesday lab.
there's no Tuesday lab, but your regular Tuesday lectures are still on.
No,
There should be no lab for 109 next week.
on the 8th.
There should be no 109 lab next week. I don't know how else I can say that. No 109 lab next week. Your lab instructor should have told you.
She tells us the night before at 9 o'clock what our labs would be next day.
It is my understanding that there's no 109 lab next week, so. Yeah, Mallory.
So we have to do one of our things count for just the class,
Mhm.
and every 2 count for the quiz, right?
So number 3 and number 5, and that's it.
Number 3 and number 5.
Right, so your 3rd summary and your 5th summary.
But so that's really only 2 quizzes.
I automatically drop one as long as you've done your first summary. So everybody gets 1 dropped.
Okay.
And then you can have more dropped if you do more summaries. Good? Good? All right, so all we're going to do today is balance redox equations. Yay! I wait all semester for this. All right, so where we left off on Wednesday, we were looking at this very basic electron transfer reaction. All right, we had copper going from copper 0 to copper plus 2, which is an oxidation. And then we had copper plus 1 reducing to copper 0, which is the reduction half reaction. So let me tell you some other things before we finish doing some practice. I guess I'll just do this. Okay, so oxidation half reactions have an increase in the oxidation number. So you know it's an oxidation reaction because the thing you're looking at should increase in its oxidation number. And you have to have electrons as a product. We also have reduction half reactions. And these have a reduction in the oxidation number. And in these, electrons will be a reactant. So the net ionic equation will be the sum of an oxidation reaction, oxidation half reaction, and a reduction half reaction. Bless you. Where there are no electrons left, the electrons will cancel out between the oxidation and reduction half reactions. So in your final net ionic, there should never be a lone electron hanging out. It means you have not balanced it properly. And just like we've done all the times before, you still have to have mass and charge balanced, right? Those two are still standard. But now we're going to have mass balanced, charge balanced, and no electrons left over. So those are the rules we've done before, but now we're starting the third one about electrons. All right, so we're going to look at some very basic redox equations, and then move up to some very complicated, and then do some challenge problems. So let's look at, let's see, what's my first one? I don't want to do that one yet. I want to do this one. All right, so here's my first equation. That's a 3. All right, just looking at it, does it seem mass balanced? Right? Looking at it, is it charge balanced? No, that is telling you that you have to break them apart and find out their individual half reactions. So now being mass balanced is not enough. Now we have a charge balance issue, which means we need to find our two half reactions, individually balance them, and then recombine them. All right, so it's not charge balance. We're going to break it into two half reactions. We're going to balance each half reaction and then recombine them to find our correct net ionic equation. So do you guys want to look at the iron half or the copper half first?
Iron.
Excellent choice. All right, what is the oxidation state of the iron as a solid? If it is not stated, what is it? It is 0. So if it's not written, it's assumed to be 0. Which it would be, right, if it's a solid, it means it's not carrying a charge or anything. So I've gone from 0 to +3. Has my oxidation number increased or decreased? It is increased. So is this the oxidation or the reduction? Oxidation, they both start with a vowel. Hopefully that'll help. Increase, oxidation. A little mnemonic. If it increases in oxidation state, it's the oxidation. Yeah?
Something kind of stupid and like derpy that I learned in high school when I did AP Chem was
Leo goes grr?
Yeah.
We're going to get to that. Yeah. For now, we're going to do increase oxidation, because we have to still have to do the anode. So we increase oxidation state at the anode. But it doesn't make a snazzy word. Increase. No. IOA. No. We'll get to Leo goes grr. We're almost ready. All right, so I've gone from 0 to +3, right? I've increased my oxidation state. So if it's the oxidation, where do I put the electrons as a reactant or a product? How many do I need? Okay. So now, are we mass balanced, charge balanced? Yes. Charge balance means over here the charge is 0, and over here the net charge is 0. So now I got 0 on each side. Good. All right, so this is the oxidation. So let's take a look at the copper half. All right, so what must be the oxidation of the copper solid if it's not given? 0. So has my oxidation state increased or decreased? Decreased. So which half reaction is this? Reduction by process of elimination, also the reduction. So if this is the reduction half reaction, do I put the electrons as a reactant or a product? And how many do I need? Okay.
Does it matter if it's Cu2 plus the 2 electrons, or can we have 2 electrons plus the Cu?
Doesn't make any difference. Mm-mm. All right, if I combine these two reactions together right now, what would be the problem? I would have a leftover electron, which violates our rules. No good. Can't have any free electrons. So what do I need to do to get those electrons to balance out? Multiply the top by 2 and the bottom by 3. All right. So now, nope. I got ahead of myself. That should be a 2. All right, so what cancels out now in my 2 equations? Just the electrons. So now we go back and we double check. Is this mass balanced? Do the irons and the coppers all match up left and right? Yes. How about my charge? Overall net charge, reactants and products. Yes. Which you wouldn't have guessed from up here, which is why we do all these steps in between to get down to this. I mean, you may have been able to guess. That's a pretty simple one. But the ones upcoming, less obvious. All right, how do you feel about that? Good? Warming up? All right, so then let's do, what do I have next? We'll jump right in and do an acid. All right, so most redox equations don't take place in water. They take place either in an acidic solution or a basic solution. All right, so pH not of exactly 7. pH less than 7, pH greater than 7. Which means we then have to be worried about how those protons are going to interact. This is not a good example. You can't balance that in acid. Just kidding. Scratch that out. What I meant was this equation over here, because you don't need acid to balance that out. You want this one. Mm-hmm. Not on my A game. I was so excited about doing these. All right, so here I have silver solid. Does anyone happen to recognize that ion? Yep, manganate. So I have silver, you've used this in lab before, making a silver ion and a manganese plus 2. Is it mass balanced? No. Which is why we're going to have to look at balancing this one in acid to, because what's wrong with my mass balance right now? There's no anything that has an oxygen in it, right? It's on one side but not the other. So we're going to have to do something about that. So let's do the same steps. Let's break it into 2 half reactions, balance them individually, and then recombine them. So let's do the easy half reaction first. We'll do the silver. All right, so what has happened to the oxidation state of my silver? Increase. So is that the reduction, the oxidation? Oxidation. So how many electrons do I need? I need 1 over here. All right, so this is going to be thinking back to, I guess, end of 108-ish when you talked about basic oxidation numbers, basic oxidation numbers. All right, ignore what's going on over here for a second. Let's just look at this MnO4. What's the overall charge of the MnO4? -1. If I had an oxygen on the periodic table, what is its typical oxidation number? Right, -2. I have 4 of them, so what altogether is the oxidation of all those oxygens? -8, right? So I have, each of them are 2, and I got 4 of them, so -8. Overall, it's -1, so what must the Mn be? +7. Yeah, let me do some other ones. Let me get another piece of paper. Little side note, little rabbit trail. Let's look at we'll look at this guy. Okay? Bromine trioxide. Okay, what's its overall charge? -1. What's oxygen's typical oxidation state? -2, right? It usually, because of the Lewis dot structure, it's typically -2. I have 3 oxygens. So altogether, what are their charges? -6, right? So I'm saying mathematically, -6 plus x equals -1. So what does x have to be? +5, which means the bromine has a charge of +5. Or what if I had we'll do this guy, MnO2. Just all these have oxygen, which should hopefully make it easier. Okay, what's the overall charge of Mn plus 2? MnO2. 0. So if I have 2 oxygens, it must be -4. So what's the oxidation state of just the magnesium by itself? +4. Good. The little mental math you have to do before you can even get the problem started.
You said it's always going to be oxygen.
Just about always. I mean, it's because we're always going to balance an acid or base, and they have oxygen in them, so. I'll do one other one. I got one more practice one. All right, so here's my chromium compound, again with oxygen. It's overall minus 2. If I have 7 oxygens, what are the oxygens charges? Right, minus 14. So then what must be the 2 chromiums together? Plus 12, which means they're individually what? Plus 6. Good? All right, now we're ready to get back to doing some redox equations. All right, so here we have our MnO4. And we just decided that the manganese by itself is plus 7. So I've gone plus 7 to plus 2. Is that an increase or decrease in oxidation state? Say decrease, so it's an oxidation or reduction. Good. So where do I put those electrons, as a reactant or a product? And how many do I need? I need 5, right? I need 5. To go from plus 7 to plus 2, I need 5 electrons. All right, if I recombine these right now, what would happen? I have some extra electrons and I still have the oxygen issue, right? So clearly we are not ready to recombine yet. All right, so when we balance an acid, we can use the following 2 compounds to help balance out our equations. Water, right, that makes sense because it's an aqueous solution. And standalone H pluses. Why could I use an H plus in acid? Because that's what an acid is, right? It should be H pluses. Good. Okay, so I want to balance these in acid using protons and water. Looking back at my oxidation reaction, do I need to do any balancing to that, or is that pretty much good? That's done. All right, so let's take a look at this guy. All right, I can use either water or H pluses to balance this out. What would be a suggestion about how to start balancing those oxygens? Okay, if we do 4 waters over here, how are those oxygens looking? They look pretty good, right? They're even, right? I got 4 over here, I got 4 over there. But what have I now made too many of? Hydrogens. How many hydrogens do I now have over here? So what do I need to do over here? Is that now mass balanced? Yes. Yeah. Only in redox chemistry. Only in redox chemistry can I just add random protons and water. If this was a regular equation, you couldn't add anything to it to balance it. Which is why I like these, because you can mess them around till they come out right. You just keep working on it. If I can't balance a regular chemical equation to save my life, these, no problem. Like I can just add water, I can add protons, I can add base, whatever I want. Just add and subtract. All right, so now that's mass balanced. Is it charge balanced left and right? Yes, good, because I have 8 pluses and 6 minuses. So that's plus 2 over here and plus 2 over there. All right. Now I need to combine this again with my silver reaction. How do I combine this one and this one? I have to multiply the top one by how many? 5. Yeah, these take a lot longer, but man, they're so fun. Like a little puzzle. Today is a ridiculously high pollen count. I was watching the news this morning. The pollen count today was 5,280. which is in the extreme pollen count. A typical day is more like 500, 600, so it's way higher than normal. So the rain should help a little bit. So if everybody's real sneeze this weekend, that's what it is. And do you know how they make the pollen count? Watched this morning. Apparently, they put a petri dish outside for 10 minutes, wait for everything to land on it, bring it back inside, put it in the microscope, and count. Yeah, there is a lady whose job at the CDC is to count pollen every morning at like 5 a.m. And all she does is she just, puts like in biology lab, right? You count colonies, same thing. It's just tick, 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 tick.
I feel like they should give this concentration.
I think there is some room for some business opportunities here. So if you're thinking of a better way to do this, there is probably a lady who would appreciate the fact that she wouldn't have to go 1, 2, 3, 4, 5. She may lose her job, but I imagine when you get towards, 5,000, you're like 500, 200, shoot, 1, 2, 3, 4. Like, how do you not lose count when you're up in the 5,000s?
Yeah, counting corn.
Yeah, I counted corn yesterday, that was tough.
Yeah,
Only like 700, but I still.
yeah, it's craziness, and those are big.
5,000 big.
Yeah, and these are like little dots. She's just taking her little pen and just, there must be a better way. So, you can be thinking about that, business opportunities.
How should they pay?
Or maybe you're a really good counter, and maybe the CDC is looking for someone. Sorry, I ran out of space. That's a solid. That's aqueous. That's a liquid. And that's aqueous. All right, ready for another one in acid? Yeah, sorry. I didn't do very practice problems in the PowerPoint because I wasn't sure how long it would take. So, we're doing good on time. Let's do another one. Alright, so here I have my bromine trioxide reacting with tin plus 2 to make bromine ions and tin plus 4 ions. There's no reason to ever do this. No, I just picked some random elements. You would never combine bromine and tin. It'd be real weird. Alright, so which half would you like to look at first? The tin half or the bromine half?
10.
Tin, it is easier. Let's do that one first. Alright, so I got tin plus 2 going to tin plus 4. Is that an oxidation or reduction? Oxidation. So where do I put the electrons? As products, and how many do I need? 2. Alright, so my tin has gained 2 electrons. Well, really lost. It's lost. They're products. Alright, so I got my bromine trioxide. This must be the reduction because we've already found the oxidation. But how many electrons do I need to complete this reaction? I need a few more than 4. 6. Alright, because this guy is going to be minus 6. This guy must be plus 5. I've gone from plus 5 to minus 1. So I need 5 to get me to 0, plus 1 more to get me to minus 1. Sure. Mhm.
I'm not gonna go on this spot
Yep.
for-
Yep, that's fine. Side note. All right, so we have bromine, O3. So I'll go through the whole thing, right? Overall -1. Oxygen is -2, but I got 3 oxygens. -6. So bromine must be -5. +5, sorry, +5. All right, so I have, in my imaginary chemistry world, bromine -5 going to bromine +5 going to bromine -1. So how many electrons do I need to get to 0? 5. How many more do I need to get to -1? 1 more, so 6. So it's super reduced, right? It actually went from plus to minus. All right, so clearly I'm not ready to combine those two reactions together yet on a few different levels. I'll just rewrite this since I got kind of sloppy. All right, it is in acid, so what are my 2 options of things I can add to it? I can have water or a proton. What would be a good suggestion to start balancing this out? Add some waters over here, right? How many waters would you like to add? 3, okay. So then what I need to do to finish balancing it? I need more than 3. 6, yep.
Is that because it's H2?
All right, so let's see. So am I now mass balanced in this? Mass balanced. Am I charge balanced? What's the overall charge on this side? -1. What's the overall charge on this one? Good. So we now mass and balance charged. Are we ready to recombine with my 2.5 yet? No. What's wrong with my 2.5? Gonna multiply that by 3. So when you guys do these for your homework, definitely, again, you're going to need to write these down. It's going to take a few steps to get them all sorted out.
We have to write our equations of our net in a certain order.
You shouldn't have to. Doesn't matter as long as they're all in there.
On the reactants on the reactant side process.
Yep. Yep. All right, now is my final equation, mass balanced. 3, 3, 6, 6, 6. Looks good. Are we all charge balanced? +6, plus another 6, plus 12, -1, and plus 12, -1. Yes. Good. How do we feel about that? Good. All right, you ready to switch it up and do it in base? I bet you are. All right, so we're going to balance the following reaction in base. All right, the technique to balancing in base is that we're going to balance pretending that we're an acid. because it's way easier just to add standalone protons than it is to add hydroxides. So we're going to balance as though we're in acid, and we're going to neutralize the reaction, hypothetically, using hydroxides. So it's pretty much what we just did with one more step. So it sounds complicated, but when we do it, you'll be like, oh, that's not so bad. Hopefully it's not so bad. All right, so here is my reaction. Which half would you like to do first, the iodine or the permanganate? Okay. All right, is that mass balanced? No. What do I need to do? I need 2 of those, right? All right, so now if I've mass balanced it, is it charge balanced? No. Where do I need to put those electrons? Who needs some electrons? The reactants or the products? Products, and how many? 2. So is that an oxidation or reduction? Okay. All right, so then let's look at the more complicated half. So we know already this must be the direction. So I'm going to add some electrons to this side. Who is changing oxidation state from a reactant to product? The Mn or the O? The Mn is changing oxidation states, right? Because we've pretty much said oxygen is always going to be -2. So it's not going to change oxidation state. The Mn is going to change. Plus it's a metal. Metals change oxidation states all the time. So what's the oxidation state of the Mn at the reactant? Yep, +7. What's the oxidation state of it over here? +4. If I've gone from +7 to +4, is that increase or a decrease? Decrease. How many electrons do I need to make it decrease? 3.
And that's how you determine the reduction.
Or I already did the oxidation, so whatever's left has to be reduction. It's just it's a double check.
Okay, because in that first one, the charge decreased.
It went from, technically it increased. It was -1, and it went up to 0. Mm-hmm.
Got it.
Yeah. Yeah, negatives are confusing. So we went up the number line. They get the number line as a up and down, where like a million is at the top, and negative millions at the bottom, and that's increasing that way.
Okay, and even though the MnO from minus looks like it went from negative up, you still
Yeah.
have to look at the Mn.
Yes. So the overall went from minus to 0, but the oxidation state actually is the thing that changed. So this must be my tricky one. Not the trickiest. We probably won't get to that today. We'll save my trickiest one for Monday. All right, so now, is this charge balanced? Not really. Is it mass balanced? No. Not really either. So, I'm going to write it on the back. That way I have more space. I'm just going to rewrite my equation, right? All right, so here's my same equation. What is one easy way to get those oxygens to start being balanced out? Add some waters. How many waters should I add? Okay, I'll start with 2. Yep. All right, so now I have 2 waters. So now I have 4 and 4 oxygens. What do I need now to add to my reactants to get those protons to add out? 4 protons. Is it now mass balanced? Mn, 4 oxygens, 4 protons. Okay. But I am in base, which means these protons don't exist, right? In base, there's no free-floating protons. So how do I get rid of those protons? I'm going to add hydroxides. If I add hydroxides, I have to add to both sides. Oh, but it's going to be equal on both sides. So, how many hydroxides do I need to add to get rid of those protons? 4. So I have to add the hydroxides to both sides, otherwise it messes up my mass balance. So you add them both sides. If I added just the one, I have to rebalance again. But I already like the balance I had. What have I now made on my reactant side? I made water. You don't have to write this as many times. I'm just trying to be thorough. All right, what's one more step I can do to simplify it? What can I cancel out left and right? Water. We're almost done. That half reaction is now balanced. Good. We had this guy up here before.
We didn't need to cancel out the hydrogen ions in the acid just because it's an acid.
Right. Yep. All right, so now how do I combine this half reaction with that half reaction? How about that? Pretty snazzy. Actually, very few people look excited by that. Okay, I get 1 or 2 thumbs up. All right, so my plan for Monday is to do a few more of these, hopefully build up your confidence. We'll do one super challenge problem, and then we will move on to how we use these actually in chemistry, talking about anodes, cathodes, oxidation reductions, batteries, how they actually are useful. These are super fascinating. I mean, these are used unto themselves. They're like a Sudoku of chemistry. We gotta get everything balanced out, all the boxes have to be filled.